In this video, we're going to walk through the process of provisioning a 3-node Kafka cluster in an AWS environment. The process we're going to follow is going to be very similar to the process that we followed in the Zookeeper example that we showed earlier. Because there's a few differences between the playbooks and the variables files, and we're going to go ahead and walk you through a few of the files in this Kafka repository before we get started. Let's start out by looking at the Kafka variables file. As was the case with the Zookeeper repository, the variables file here is meant to represent the values that probably won't change much from one playbook run to another. There is an application defined in this file. It's Kafka, obviously. But there's also a Kafka distro, or a distribution. This playbook supports deployments of both the Confluent Kafka distribution and the Apache Kafka distribution. So if you change this Confluent value to Apache, this playbook will install the Apache distribution instead. As was the case with Zookeeper, the Kafka data directory is the directory under which the Kafka logs should be placed, and it'll create a /data/Kafka subdirectory and put the Kafka logs for the various topics into that /data/Kafka subdirectory. The Kafka dir of /opt/Kafka is used for the Apache distribution installation process. And that's because the Apache distribution is actually installed from a gzipped tar file. The Confluent packaging is as an RPM file, a Red Hat Package Manager file. And so it installs into the normal locations for executables and config files and all that, /etc and /userbin. It installs into the normal locations. So this Kafka dir is really only used for the Apache distribution. In addition, there is a Kafka topics list defined in this file. These are the default topics that should be created, and we create a metrics and logs topic because we use these with the telegraph agent that we deploy to the nodes of the DataNexus platform for management purposes. And it collects metrics and logs and expects to be able to report them to an associated, the telegraph agent expects to be able to report them to an associated Kafka cluster. Each of the entries in the topics list is a dictionary with a name, replication factor, and a number of partitions. And I think if the replication factor and number of partitions aren't specified, there are reasonable defaults for those based on the cluster size. In addition, we define, as was the case with the Zookeeper ensemble deployment, a package list. This is the list of packages that must be installed for Kafka to run on these nodes, regardless of the distribution. And it's the OpenJDK packages, since Kafka runs as a Java process, just as was the case with Zookeeper. As was the case with Zookeeper, there's a user and group that are used to control the user and group that own the installation and that the service is run under. Those both default to Kafka and probably don't need to be changed. The Scala version and Kafka version specified here are used with the Apache distribution, and they help us establish where the Apache distribution should be downloaded from and which file should be downloaded from that Apache distribution site. The Confluent repository, or Confluent distribution, as I said, is distributed as an RPM file, and these are the parameters that you have to define in the Confluent example to constrain which version of Confluent is installed on your platform. We install by default the open source version of Confluent. There is a commercially licensed version of Confluent. We really haven't tested this playbook much with the commercially licensed version. We've installed it, we just haven't tested any of the commercially licensed features. This OS release version is actually the major version of your OS release. So CentOS 7, RHEL 7, they both are 7. And this is used to actually construct the location that the RPM file should be obtained from. As was the case with Zookeeper, there's a private key path, and that private key path defaults to the playbook directory. There is the ability with this local Kafka file to upload files from the Ansible host, the host you're running this playbook from, rather than downloading them from the online repositories. I'm not going to go into the details of doing that, but there are some environments where this is a handy feature to have. There are 3 ports defined here. The port that the Kafka nodes are going to listen for plain text communications, the port where they're going to listen for SSL communications, and the schema registry port. The schema registry port is used in the Confluent distribution, not in the Apache distribution. And those correspond to the schema registry service and the Kafka service. In addition, as was the case with Zookeeper, there's a node map. By default, it's set to deploy a 3-node Kafka cluster and a set of application security group rules that you probably don't need to change. These are related to the ports that were defined up here. As you can see, the plaintext port, SSL port, and schema registry port are all set up to be open on the external subnet. The internal subnet is opened on port 2181 so that these Kafka nodes can talk to the associated Zookeeper node or ensemble to elect a leader in a clustered Kafka deployment. The provision Kafka playbook itself is quite similar to the playbook that we showed you for the Zookeeper repository. The only difference here is that we are creating host groups for both the Kafka nodes and the Zookeeper nodes. And if you go through the playbook, it'll look very similar right down till we build our app host groups. And you can see we're passing in a list of the application names that we want to build host groups for. And once we've built the host groups, it goes ahead and counts up the number of nodes in the Kafka host group and the Zookeeper host group. And if it finds existing Kafka nodes, and the user did not set the reuse existing nodes flag to true, as was the case with the Zookeeper playbook, it fails. But in addition, if it finds that we're trying to do a clustered Kafka deployment, and the number of Zookeeper nodes that was found is 0, then it also fails, because we need to have that external Zookeeper node or ensemble in a clustered deployment for those Kafka nodes to discover each other and to elect a leader. Assuming that we found some Zookeeper nodes already in the environment, and we will in this example, and assuming that there were no Kafka nodes in that environment, we then come back into a very familiar part of the playbook. Here we're launching AWS or OSP nodes if we're in an AWS or OSP cloud environment based on the number of nodes in the node map, in this case 3. Once we have launched those nodes, the next play completes the OS configuration for the Kafka host group. And again, we're loading the Kafka variables file, we're initializing this play, we're calling that pre-flight role that we showed in the previous video. And then in the third play, we gather the facts associated with the nodes in the Zookeeper host group. And this is done by calling the setup task, which is the default if the number of tasks is empty. And then we come down into the final play of the playbook. And again, we're targeting the Kafka host group in this one. And what this does is goes through and initializes the play, sets a fact associated with the Zookeeper node so we can use that later in the playbook, and then calls the Kafka role. And as was the case in Zookeeper, the Kafka role is found in the tasks subdirectory, and it's the main.yaml file here. And you can see, again, we're going to install the required packages. We're going to add the Kafka user. We're going to call an installation tasks file, or include an installation tasks file that's specific to the distribution, since the 2 distributions are installed differently. We will call a role, or include a role to configure the Kafka nodes. Then we'll create the Kafka services. There are more than one of them. We'll enable them on boot. We will start them. We'll pause for 10 seconds here. And then once we're done with our pause, we'll go ahead and create those Kafka topics that I showed earlier. So all we got to do to get started here is we got to customize this configuration file, this default configuration file. And as was the case with our Zookeeper, I'm going to create a config AWS custom file, and I'm going to add those two tags that I added previously. So data flow pipeline and cluster A. These tags need to match the tags that I used in the previous Zookeeper playbook run so that I can discover that Zookeeper cluster or ensemble. In addition, I'm going to go ahead and select my specific image that I know works well for me, and everything else I'm going to leave at the default values. And then I can just run my provision Kafka playbook. As was the case before, we set our AWS profile. We execute the provision Kafka playbook as a command using the shebang line in that playbook, and we pass in our custom config file as a config file extra variable. As was the case with Zookeeper, this will go out and build the app host groups, but it's doing it for both Kafka and Zookeeper now. It found some Zookeeper nodes because I have Zookeeper nodes already running in this environment that are tagged appropriately. It did not find any Kafka nodes, so it's going through the process of actually creating the AMIs that it's going to use for that Kafka cluster and tagging them appropriately. You can see as you go through this example that, as was the case before, it's creating a security group for internal and external. It's attaching that security group to these nodes. It's associating a private and public key pair with those nodes and making sure that that private key lives on the local directory. And now it's going to go ahead and create those data volumes, those 40 gigabyte data volumes, and attach them to the instances. And this does take a little while, so I'm going to pause here, and I'll come back momentarily when these data volumes have been created and attached to the instances that we just launched here. All right, so it has created the 3 data volumes and attached them to the instances that we created when we launched these AMIs. It's also now creating the public internal ENI and attaching that as F1 on these instances. And once that's done, it's going to go ahead and create some elastic IPs or allocate some elastic IPs and attach those to those ENIs. So we'll have externally routable IP addresses associated with them. That should be done here in a moment. And then once those are attached, it's going to go ahead and create our application host group and add those nodes to it. And then it's going to wait for those nodes to become available via SSH before it proceeds with the rest of the playbook, because we're going to need to attach through SSH to those instances from our Ansible host in order to run the rest of the plays in the playbook. Again, this should just take a couple of minutes. It's fairly short. Once that's done, it's going to go back and go through that process of finalizing the configuration of these 3 nodes that we just created, the 3 new Kafka nodes. And again, that happens in a play that's very similar to the play you saw for Zookeeper. You know, setting up no default route, restarting the networking after creating the eth1 ifconfig file. Once that's done, building the file system and attaching that mounting it under /data, configuring the SSHD correctly and restarting it, generating our UUID and using it to set a host name on the system so that we all have unique host names, and then stopping postfix and removing it. Once that's done, we go back and discover the facts about the Zookeeper nodes, because we need to know, for example, the IP addresses of those Zookeeper nodes on the proper subnet. And then we go into the play that actually installs Kafka and configures our nodes as a Kafka cluster. And again, you'll see this is very similar. There's some initialize play stuff up here, and then we go into the Kafka role itself, which is, in this case, installing the OpenJDK packages. And then once the OpenJDK packages are installed, that should only take a minute or so here, creating the Kafka group and user, adding the RPM key, and creating an entry for the repository, and then installing Confluent from that repository. And this takes a little bit of time because Confluent's a fairly large package. And then once Confluent is installed, it's going to go back through and configure the nodes so that they will all be a part of a Kafka cluster, and so that they will talk to the external Zookeeper ensemble that we're integrating this Kafka cluster with. And again, this takes a minute or two to get through the process of installing Confluent from the main Confluent repository. You can upload a bundle of RPM files from the local system if you don't want to download it from Confluent and install it from there. And in some environments that may be faster. We're going to go ahead and create our data and log directories. Go ahead and configure Kafka so that it's listening on the right ports and talking to the nodes are all talking to each other. Create our service files, restart things, enable them on boot, and then once we got that done, we can go ahead and start Kafka. And once Kafka is up and running, start the schema registry service. We give it a little bit of a pause between the two. And then once that's done, we pause for another 10 seconds or so before we create our topics from that Kafka topics list. And then we go ahead and set up the connection string so that it'll talk to Zookeeper. And we're done. So you can see we've created 2 logs here, and I'm just going to pick I'm just going to go ahead and pick one of these nodes, say 138, 129, doesn't really matter which. And I gotta change the path on this key. This is from a previous example. So I'm going to change the path to my local directory, which is temp Kafka. And now I can do a Kafka topics. And I think it's let's go ahead and do a help. And then let's grep out of there. And you can see there's my Zookeeper string. So I can do a Kafka topics minus Zookeeper and give it that. I probably have to put quotes around it because of all the colons and commas in there. Got to tell it what to do. List. There we go. So we've got a logs and metrics topic in here. So that's where we're at. We've deployed Kafka to our 3-node Kafka cluster. We've integrated it with our external Zookeeper ensemble. And you can see now I have 3 Kafka nodes and 3 Zookeeper nodes running in my AWS environment. And I've created a logs and metrics topic, and that logs and metrics topic exists across all of my nodes. So that's the demo of deploying Kafka to an AWS environment. Hope you've enjoyed it, and we'll talk again soon.